Welcome to Test Review with Mrs. Cox. We are on Chapter 8, Form 2A. Now your test looks a little bit differently than mine. You actually have some numbers here of composite numbers. You have like a 5. Oh, I gotta turn markup on. Silly Billy. There we go. Now let's try this again. So you have a 5. Nope, wrong one. I'm going to get it right one of these times. A 5, a 7, a 13, and a 16. So you need to look at these numbers and also look up at our math wall where it says prime and composite, and you will find the answer there. A composite is a number that has several multiples that will go into it. So 1 and itself and lots of other factors will go into it. Prime, think of Optimus Prime. There's the one and only Optimus Prime. And up on the math wall, there's this definition too. It's when only 1 in itself will go into it. So you have a 4 and a 6 and a 9 and 11. So looking at those options and looking up at the math wall, do you see one of those numbers on that card that only 1 in itself will go into? I'll tell you right now, it is not 9, because I know 3 times 3 goes into it and 1 times 9 goes into it. And I'll let you guys figure out the rest. GCF of 6 and 15, this is where you take 6 and 15 and write all the factors, starting with 1. 1 will go into it, times 6. 2 will go into it, times 3. 3 is already labeled and counted for. 4, nope. 5, nope. 6, nope. Okay, we're done. 15, start with 1. 1 will go into it, times 15. 2, nope, it's not an even number. 2 won't work. 3 will work. 3 times 5 equals 15. Let's see, 4, nope. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Nope, that's it. So the greatest common factors, you look at those two sets of numbers that you have there, and you find a number they both have in common, the biggest number they both have in common. And that's the number you circle. Okay, looking at 4/16, we see if we can be ninjas and chop that in half. Looks like we can at least chop it in half, or sometimes what I like to do is I like to look at that numerator and say, hey, 4 will go into that, and I know that 4 will go into that, and that might help you solve your problem. Also, 2 will go into both of them as well, and you just have to do it again and divide it by 2. Prime factorization, so this is where we do a Christmas tree. So we take 56 and think of the factors that make 56. So we can, it's definitely even, so we could just go ahead and divide it by 2. But I know that 7 times 8 equals 56. Now 7's prime, it can't be broken down any smaller, but 8 can be broken down into 2 times 4. 2's prime, but 4 is not, so I can cut that down a little bit more too. Now you're not done. Prime factorization asks you to then order them from littlest to biggest. So I have 1, 2, 3, 3, 2. So 1, 2, 3, and then I have a 7. So do you see that answer somewhere? Okay, 98. Do the same thing. It's definitely a number that can be split, divided in 2. So I'm going to let you come over here. You have to do the division math to figure out what 2 numbers will go into 98. 2 and some crazy number, and then that crazy number can be split into 2 other numbers. Then you need to order it from least to greatest, and that will be your answer for number 6. Okay, number 7, least common multiple. I wish they would just write skip counting. Okay, so we are going to list 5 and 6 and skip count. Or you can just go down your times table chart that's on your desk. It's easy peasy, lemon squeezy. 5, 10, 15, 20. 25, 30. Okay, now 6. You've got 6, and you keep on going until you find a number that it has in common with 5. When you get to that number, you circle it and put it on the answer line. Okay, number 8. We have 3 and 6 and 8. Now, these are all on your times table chart. So you can go through and skip count. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. There you go. Okay, now you can do your 6s. 6, 12, and just keep on going down your times table chart. 8, start with an 8 to skip count. 8 times 2 is 16. 8 times 3 is 24. And skip count. Now, I want you to look and see if there's a number all 3 lines have in common. You have to do your skip counting at least 4 or 5 numbers in until you find a similar number that all 3 of them have. Okay, number 9. I've gotten a lot of people really confused with this. You cannot compare this until you have the same denominator, and those denominators are not even close to the same. So to make the same denominator, you do 2/3 and you stack them in 2/5. So a number that both 3 and 5 will go into, well, sometimes I just like to multiply them. 3 times 5 is 15. They both go into 15. 5 goes into 15 3 times, so whatever you do to the bottom, you have to do the top. Whatever you do to the bottom here, you have to do to the top. So 2 times 5 is 10. 2 times 3 is 6. Now this is where you have to make sure you keep track. So 2/3, the equivalent fraction is 10/15. So I'm going to write 10/15. And then 2/5, the equivalent fraction is 6/15. All right, you now need to put a less than, greater than, or equal sign in that bubble. Are one of those fractions bigger than the other? You tell me. Okay, number 10, this is where we also need to stack them. I'm going to use my work pay place right here. Because I need to stack them and make them into equivalent fractions. So a number they'll both go into, you could just times them. 5 times 10 is 50, but that's a really big number. I happen to know that 5 will go into 10 and 10 will go into 10. That saves me a lot of work on simplifying at the end. So 10 goes into 10 once, times 1, whatever you do to the bottom, you have to do to the top. Number 5, or 5 by 4s, 5 will go into 10 twice. So 8 times, or 4 times 2 is 8. Love how I say the answer. Okay, now this is where you got to make sure you write the right equivalent fraction under the right fraction. So 4/5 is equivalent to 8/10. 7/10 is equivalent, well, to 7/10. Now you're in charge of putting a greater than, less than, or equal sign there. Okay, figure it out. Charlotte is making a scrapbook. She needs a piece of ribbon that's 3/4 of an inch long, or 3/4 of an inch long. What is the fraction written as a decimal? So on decimals, you have to make it either convert it to a 10th, a 100th, or 1,000. Which one of those would be easier to convert 3/4 to? I would say 100. Think of quarters. There's 5 cents. You can get 4 quarters in $1. So whatever you do to the bottom, you have to do to the top. So 3 times 25 is, very good. Now you need to write that as a decimal. If you look on your desk, you'll see a handy dandy little chart that'll help you figure out how to write that as a decimal. Okay, 24/25, same story. Are we going to write it? Can we convert it to 1/10, 1/100th, or 1/1000th? I'll let you decide. And same with 13. Looking at 1/2 as a decimal, can we convert that to 1/10, 100th, or 1/1000th? Figure it out and write your decimal. Okay, number 14. Remember, this is the social media one. Very similar to that one I was telling you about where the dad got 200 different comments on it. Now think about it. Can you chop up people or pizzas? One you'll get thrown in prison, one you'll solve this problem. Whatever one you can chop up, you put on top. So there's going to be 2 pizzas And 8 people are going to have to share them. But that is not your answer because I'm pretty sure you can be a ninja and you can simplify that answer by chopping it. So figure out the simplified version and give me the answer, folks.